Okay, going to start out here. And take note, we're going to start with chapter 3. So we'll start with 3 and then go to 4 and 5. So we start out with pure compound in a substance. A substance is a single kind of matter that is pure, always has a specific makeup. So our example is going to be the salt. Compound is a substance made of two or more elements that are chemically combined. And here we're going to go with our water. Types of mixtures and what their differences are. If you remember, we went through quite a few of these. Heterogeneous, we can see the different parts. And would this be pizza or salt water? Okay, going to be the pizza. Homogeneous, you cannot see the different parts. Of course, that's going to be the salt, because the salt dissolves and you cannot see it, even though it is a mixture. And of course, we can separate those. So how do we separate mixtures? Okay, so as we take a look here at these examples, we're going to start here to the left, and this is going to be magnetic attraction. Underneath, we did in class, and this is going to be evaporation. We'll jump up top to the right, and we take and go through a filter. This is going to be filtration. And from our last example here is going to be distillation. So these are 4 examples of how we can separate a mixture. Okay, chapter 3 here, how to determine the volume of an irregular object. You're going to use a graduated cylinder. Directions are right here in the box. We're going to fill it. It says 2/3. A lot of times we would fill it up to 50 if we have a 100 milliliter graduated cylinder, and then it's pretty simple to see the difference. So if we start at 50 milliliters and it moves to 55 milliliters, then we are going to end up with 5 for our difference. And if it is a solid, then we have to change that to centimeters cubed. So don't forget that when you're trying to find your answer. Still in chapter 3 here, I'm going to identify an unknown object based on its density. And we have worked pretty extensively here with mass divided by volume. That is one formula that you will be expected to memorize on this test. Identify and know the difference between chemical and physical changes and properties. So we start with physical property. That's going to be observed without changing it into a new substance. A chemical property will describe its ability to change to another substance or substances. Sometimes, of course, we have multiple things produced. Physical change is a product still going to have the same substance after the change. Break a board, cut a piece of paper, etc. And you've got a chemical change. That's a change that's going to produce one or new substances. Endothermic, exothermic. In endothermic, the heat goes in. Emphasize the in and the en at the beginning. And for exothermic, it's going to exit and exo. So I think those are 2 simple ways to take a look. Examples, which one of these is endothermic and which one is exothermic? Endo goes with the ice, and exo goes with the fire. Okay, now we're switching to chapter 4, how the molecules, particles behave in each state of matter. I think this is important to understand and be able to recognize. This is something that we struggled on the quiz. A solid can only vibrate in place. Liquid can slide around one another but still touch. It's going to have a definite volume but not definite shape. And gas particles spread apart to fill an entire container, and they never have a definite shape or a definite volume. And I think one thing to understand on the difference between these, typically when you see a solid, it's going to show bonds between them. A lot of times you're going to see lines. They're going to be packed into a container. Liquid can still have as many showing, but they're going to have a little bit more space between them, and then gas are going to spread out. And those may only show a couple. In the picture, but it's still gas because of the way they're spread out. Difference in properties between the three states of matter. We've got liquid properties, surface tension. So you can see this bug here shows surface tension. And then we have taken a look at this picture over here before with viscosity and see the difference in how these 5 samples flow. Okay, still in chapter 4 here, going through some changes. Melting, particles vibrate so fast they break free. Vaporization, it's when they gain enough energy to move independently. Sublimation, particles of a solid do not pass through the liquid state when they form a gas. So they go straight from solid to gas. Condensation and freezing. And we've talked about a lot of these. I think important thing to note here, all of these are either absorbing or releasing energy. So they have to gain energy or release it in order for these things to happen. Difference between crystalline and amorphous solids. Again, this was in the book, a part of your reading. Crystalline are made up of crystals, and you should be able to see that root word in there. Amorphous are not arranged in a regular pattern. They do not melt at a distinct temperature. So you have glass, plastic, and rubber as examples. Concept of viscosity depends on the size and shape of its particles and the attraction between its particles. Stronger the attraction, the slower it moves. So as you saw that previous slide, you can see a large difference. So if you think of water as having a low viscosity, pours very easily. And then if you're going to put honey, add it to a recipe, you may wait a minute if that bottle is fairly low as it moves to the spout to add to your recipe. And then we've got all the changes of state here below and what they go between. So what they start as are over here on the left, and what they finish as are over here on the right, and then down the center is the type of change that it goes through the term. Okay, know and applied Charles' law and Boyle's law. Again, we've done quite a bit with this. I think the only thing to emphasize is that Charles' law, when one increases, the other increases, and you can see the picture here. And with Boyle's law, when one is increased, the other decreases. And again, we've got a picture down here. So as pressure increases, we push down, the amount of space available shrinks, and then you can see the temperature readings here and here, and compare those as to how much space they end up with. Chapter 5. Now this is what we just took our quiz on Friday. Energy is the ability to do work or cause change. How to calculate power. Some of these formulas, we've already brought up density, but these other formulas that are listed on here, they will be available on the screen. So you do not need to memorize these when we do power and we do kinetic energy. And kinetic energy is going to go here in the box. So we're going to do the first one together here. So our formula is 1/2, and I'm going to do the dog here. So the mass of the dog is 20, and then the speed, the velocity, is 2 meters per second, and we're going to square that. So I've got 1/2 times 20 times 4. Continue to bring that down to 1/2 times 80. And then my answer is 40 joules. And that's the correct unit for kinetic energy. So I'm going to give you just a minute here, pause this, and go ahead and figure, using that same process, the mass that the girl has. So pause it now and figure that out. Okay, check your answer here. You should have, for the girl, gotten 120 joules. So hopefully you ended up with that. And then finally here, let's pause it again. The dog speeds up and is now running at a speed of 4 meters per second. So figure, if the dog's running faster, the kinetic energy. Pause it. Take a minute to answer that. Okay, and the dog with that increase, ends up at 160 joules. Types of energy here are all listed on the left-hand side. These definitions should be all in your notebook, in your glossary, so you can use that to help you understand which type of energy is which. Okay, calculating potential energy. Potential energy equals weight times height, mechanical, potential plus kinetic. Again, these will be on the screen. You do not need to memorize these. The only one you need to know for the test is density. How energy is transferred and what happens. We've talked about this a little bit. Conservation, law of conservation of energy, as you look below, also goes with it. But all forms of energy can be transferred to other forms of energy. And the amount of energy does not change. It just transfers to another form. And this goes into the definition that it can neither be created nor destroyed. Total energy is the same before and after any transformation. So we've got some videos again that are on my big campus that you can take a look at that are, of course, very interesting. Okay, so you've got to apply the concepts of potential energy and kinetic energy to real-life situations, and we've talked about this in class. If this is the arc, whether it's a roller coaster, throwing a ball, whatever it is, potential energy maximum is going to be here, and kinetic is going to be here. So we've drawn these already. These should be in your textbook. You can also take a look at page 172 and 73 in your textbook.